Welcome back, geometry students. We are actually going to talk about more solving today. So this is like video number 5 on quadratic. So we're going to talk a little bit about remembering how to do completing the square. I'm going to show you a little bit more complicated version of it. We're going to talk about how the quadratic formula came about, and then really how to use the quadratic formula. So that's kind of be the basis for this video. All right, so we're just going to call this solving continued, because that's what we're doing, is we're continuing our process of solving. So the first thing I want to talk about is this completing the square. And so I know we talked a little bit about this when we did circles. So you may have a little bit of an understanding of this, right? So you have, some of you were great at it, some of you were a little bit weak at this, so this will be a nice review. So let's go ahead and kind of use an example to kind of walk us through the process. So the first example I'm going to give you is something relatively basic. What I mean by that is like your a term. So the number in front of x squared is going to be 1. And then I'm going to show you how to do that when the a term is not 1. All right, so if you remember the steps, and so if you need to write these down, go ahead. First step is to move c to the other side of the equal sign. All right, so on our scenario here, we're going to go x squared minus 8x, and I'm going to subtract 15 from both sides. All right, step number 2, we're going to divide by the a value. Now, in our scenario, our a value is 1, so we don't really have to do anything here, because obviously dividing by 1 is not going to do much to our problem. Step 3 is kind of the big one. This is where you take half of b, so remember b is that number in front of x, square it, and then the kick here is, and this is what I saw some mistakes on when you did circles, you want to add it to both sides of your equation. So if we're looking at our equation here, half of b, so b is -8, half of -8 is -4. Square it. -4 squared is 16. So we're going to add 16 to both sides of our equation. What this does then, by doing that, we get this left side, this side right here, to be a perfect square trinomial. And so now our next step is to factor that perfect square trinomial. And so a perfect square trinomial factors into the format of like basically the same parenthesis twice. And so it's in our group here, we have kind of the shortcut way is to take the square root of the first value. So the square root of x squared is x. The square root of the last term, which is 4. Whoops, I forgot to make this a plus, sorry. We add 16 to both sides, which is why that is a plus. And then whatever this middle sign is here is what goes inside your parentheses. So this perfect square trinomial factors into x minus 4, x minus 4. If you were to FOIL out x minus 4 and x minus 4, you would get x squared minus 6x, or minus 8x plus 16. And then over here, if I added -15 and 16 together, I get +1. All right, the last step in this process is to solve, and then I want you to solve by taking the square root. So this is basically a vertex form equation. So now what we're going to do is we're going to square root both sides. Don't forget your plus and minus. So I have x minus 4 equals plus or minus 1. Let's solve for x by adding 4 to both sides. And we know that the square root of 1 is just 1. And I'm going to write my answers as 2 separate answers. So +4 plus 1 is 5, and +4 minus 1 is 3. So those are our 2 solutions. We're not actually finding x-intercepts here. I mean, we are, right? Because those could be our x-intercepts. But since I asked you to solve it, we're going to leave our answers as x equals, since that's kind of how we write solutions. All right, let me show you how to do one where the a value is not 1. Okay, so the a value is not 1. The process is still the same. So let me show you. So here's our trinomial. We're going to solve this by completing the square. So step number 1 is to move c to the other side of our equation. So I'm going to subtract 12. Next step, I'm going to divide everything by my a term. Since my a term is -4, I'm going to divide everything by -4. And so what I get here is x squared minus 2x, not 4x, equals 3. So I get x squared minus 2x equals 3. Now we continue on. We're going to take half of b, square it, add it to both sides. So b is negative 2. Half of negative 2 is negative 1. Negative 1 squared is positive 1. So we're going to add 1 to both sides. This is going to be a perfect square trinomial. So this factors into x, and then the square root of 1 is 1, with the middle sign being negative. And then we're going to solve by square rooting. So I'm going to square root both sides. I get x minus 1 equals plus or minus 2. Don't forget the plus or minus. And then let's just add 1 to both sides. So plus or minus 2 plus 1. I get 2 answers here again. So positive 2 plus 1 is 3. And negative 2 plus 1 is negative 1. So my two solutions are 3 and negative 1. All right, let's do a little work with kind of the proof of the quadratic formula. So did you ever wonder where this quadratic formula came about? So if you remember what the quadratic formula is, and you probably have at least seen it before, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's kind of a weird formula just to have someone create that on its own. And so the answer to that is actually it was not created on its own. It's actually part of completing the square. So what I'm going to show you next is how to take our general, like how this formula came about. So what I'm going to do is I'm going to start with our general equation. So our standard general equation. So I'm going to use ax squared plus bx plus c. I'm going to take this equation, which is in standard form, and I'm going to complete the square. And where we're going to end is right here. Let me show you how it works. So step number 1, take c and move it to the other side, right? So we're going to subtract c. Step number 2, divide by basically your a term. So my a term, well, is a, since we're using just letters here. So I get x squared plus b over ax equals negative c over a. All right, here comes the fun part. Take half of b, square it, add it to both sides. So let's do a little work here. Half of b. So b is actually the number or the values in front of x, the coefficient of x. So half of b over a, which equals b over 2a. We're going to square it. So that means we're going to multiply by itself. So that's like b over 2a times b over 2a, which is b squared over, b squared over 4a squared, right? So if we take half of b, square it, and now we're going to add it to both sides of our equation. So I'm going to add b squared over 4a squared to both sides of my equation. Okay. The next step of this is to make this is a perfect square trinomial. It doesn't really look like one because of all the weird letters, but because we did the process, we know that this is a perfect square trinomial. So the square root of b squared over 4ac, we already did that, was b over 2a. And then obviously the square root of x is x. Since this is plus, we're going to make that a plus sign in here. So now we're going to do a little work over here. We are going to make this into a common denominator. Okay, so I want to add those two fractions together. So my common denominator here between a and 4a squared is going to be 4a squared. So all I'm doing here is I'm just making this denominator to be 4a squared. So I'm scaling it up. So to get from here to here, I had to multiply by 4a, which means in order to solve that fraction, I have to multiply the numerator by 4a. So I get negative 4ac. So now that my two fractions, these two that I'm adding together, have the same denominator, So when you add fractions, you keep the denominator and you add the numerators. So b squared plus negative 4ac is the same thing as saying b squared minus 4ac. Now you see where that's coming from. So on this side of my equation, all I did here was added fractions, but in order for me to add those fractions, I needed to find a common denominator. So I scaled this fraction up by 4 times a, because in order to get from a to 4a squared, I needed to multiply by 4a. So once I did that, I combined like terms, right? Kept my same denominator, add the numerators, and that's where I'm at. All right, next step. Let's solve. Let's square root both sides. So I have x plus b over 2a equals, don't forget your plus or minus. And the square root of a fraction, if you remember when we talked a little bit about this, you take the square root of the top and the square root of the bottom. So it looks like that. Let's clean this up before we kind of do anything else. So I'm going to go x plus b over 2a equals plus or minus the square root of b squared minus 4ac. If you know what the quadratic formula is, we know that we want to keep that. But the square root of 4a squared, the square root of 4 is 2. The square root of a squared is a. So that's where that 2a is going to come from. Okay, a couple more steps. Let's subtract b over 2a from both sides. So I'm just subtracting, moving this to the other side. Notice these are two fractions here. One fraction, another fraction. Notice they have a common denominator. So let's rewrite this as one common denominator. So add the numerators together. There you go. That's where the quadratic formula comes from. It's taking a generic or your standard form equation without the letters, or without the numbers, just with letters, and then completing the square. And that's where that quadratic formula came from. We didn't just like create it out of the thin blue sky. So that's kind of the process. This is the proof for the quadratic formula. All right, let's do some more math. So let's do we'll do 2 examples of quadratic formula. So I'll show you. So let's start with 1. So when you solve something using the quadratic formula, first of all, you need to set the equation equal to 0. So in this case, I'm going to subtract 6. Remember, if it were factorable, I would factor it. Now, see how there's a GCF here? You are always welcome to factor out a GCF. And so I would encourage you to do that just because then it makes your number smaller and easier to deal with. So I'm going to factor out a 2. You could factor out a -2 if you really wanted to, but again, either way, we should all end up at the same spot anyway, whether we factored out a -2, a +2, or if we just left it as -4x squared and plus 8x plus 6 and did the quadratic formula from this step. I like to use the smaller numbers just because, again, like I said, it makes things a little bit easier as we go through. So now what I'm going to do is I'm going to use the quadratic formula on this trinomial. Remember how when we factored out a 2 and we solved by factoring, that 2 has no bearing on our equation. It's just like a scale factor. It's just scaling it up. But when it comes to our solutions, it really has no bearing on our solutions. So now I'm going to use the quadratic formula on this trinomial. So the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's plug in our numbers. So -b would be -4. Plus or minus b squared, which would be 4 squared, which is 16, minus 4 times a, which is -2, and c, which is 3, all over 2 times a. Be careful the way you write this. Probably the biggest mistake I see is that a lot of people put, this whole numerator is being divided by 2a, not just the square root part. So the whole thing is being divided by 2a. This -b is also being divided by 2a. So just be careful there. You could do this in your head, or you could grab a calculator. So if you grabbed a calculator, what I would do, we call this part the discriminant, which is actually going to be in the next video, but I would do 16 minus 4 times -2 times 3. So what I would like to see here is the number underneath the radical, and we call this the discriminant. I would like to see this step. So one of the other things that I'm going to ask that you do is I'm going to ask that you write your answers in reduced radical form. which means that you need to reduce your radicals. So with 40, we're going to reduce 40. Remember that 4 times 10 is 40, which means the square root of 40 is actually 2 root 10. So now I'm going to replace root 40 with 2 root 10 over negative 4. There's two ways you're going to see this simplified. So this is not quite simplified. One way is, if you notice, all three of these numbers here, okay, you can't count the number underneath the radical because it's a separate value. So we're only looking at the kind of the whole numbers. If all of those numbers are divisible by the same thing, like in other words, all of these numbers are divisible by 2, we can go ahead and simplify it. And so if I divide this by 2, I get negative 2. Divide this by 2, I get 1. If I divide this by 2, I get negative 2. So you can see it simplified like that. That's one option. A lot of times you won't see a negative on the bottom of a fraction. And so what they will do is throw the negative on top, which just means you're going to multiply everything in the numerator by negative 2. So another equivalent way of writing this is 2 plus or minus root 10 over 2. Because all I did is multiplied this numerator by negative 1. And because of this plus or minus, me calling this plus or minus 10 or root 10 or plus or minus negative root 10 doesn't really change our value any. So that's another equivalent way. The one way I normally write this, though, is what we call an a plus bi form, which basically means you're dividing, like the numerator's in two parts. I'm going to divide negative 4 by negative 4, and I get 1. And then I'm going to divide 2 root 10 by negative 4, and I'm going to get plus or minus root 10 over negative 2. So I like to write it in this format where I'm kind of taking those as separate. So I'm taking this negative 4 over negative 4, getting my answer, and then plus or minus, and then this chunk over negative 4 and reducing that. This is the format I generally use, but notice that there's other equivalent ways of writing it. Now, of course, you can use a calculator to get decimals. If I was asking you for like x-intercepts, that's what I would want you to do here. But since I'm not, I would have you leave this in reduced radical form. All right, last example. Let's try one where we have 2x squared minus 10x minus 5. All right, let's go ahead and use quadratic formula. So we could try to factor this one, but obviously this is a whole video on quadratic formulas, so we're going to go ahead and just go straight to quadratic formula. All right, negative b. Well, negative 10 is like saying positive 10, plus or minus the square root of b squared. So negative 10 squared is 100. Be careful if you plug in negative 10 and square it on your calculators, you're going to get a negative number unless you put it in parentheses. So if you're going to put it in your calculator, make sure you put that in parentheses. Minus 4 times a times c all over 2 times a. All right. So you get 100. Oh, I'm going to go ahead and put this in my calculator here. So I'm going to do 100 minus 4 times 2 times negative 5. So I get 140 underneath this radical. So I get 10 plus or minus root 140 over 4. So let's reduce that radical. Let's think of the largest perfect square that can go into 140. Well, let's try 4. 140 divided by 4 is 35. And 35 is 7 and 5, but that doesn't give me anything. All right, so we can reduce this to 2 root 35. All right, so now I have this. Let's reduce our answers. So again, you can write this in two different ways. You can notice that all three of these digits are divisible by 2. So you could write this as 5 plus or minus root 35 over 2. That's one way you'll see it. Or again, you can kind of think of it as two separate ones. 10/4 is like 5 halves, plus or minus, and then this would be root 35 over 2. So either answer would be acceptable. Both of those are correct. All right, that's kind of completing the square and your quadratic formula. If you have any questions, let me know. Thanks.